So dependent sources, I went through this just now. Dependent source is a source in which the output depends on a different part of the circuit. All right, there are two types. You have the dependent current, dependent voltage. So on top here is a normal battery like your customer and a normal current source. All right. At the bottom here you have the dependent ones, which you see in the diamond. So there's a dependent voltage source and there's a dependent current source. That's like I said before. All right, so just keep your eye out for it in the circuit. Okay, you treat with those things separately and differently, like how you do a normal. Yeah, these things here will either make or break your system of equations. Okay, it could trick you up a lot because it's not a normal battery. It depends on somewhere else. All right, so let's be careful with it. So we continue. All right, supernodes. Um, I'll go through this, but I want to try to put a question, but I'll just go through it. So a supernode, as I said, it occurs when there's one or more voltage sources between two unknown nodes, just like I explained it before. It doesn't have to be one battery. It could be something like this. If you have a resistor here, you could have a battery, then you can have a next battery, yeah? Then you could have a next battery and a resistor. You can have something like that. You don't have to be like one voltage source, yeah? But all you would do, so you have node here, node here. So you have voltage sources in between two unknown nodes. That's like I said before, doesn't change. All right. So the steps to make a supernode, you appreciate this when we do it after. But to make a supernode, we'll include the node before. So I'll explain this more when you actually do a question, right? But we include the node before the source, which will be this one here, and the voltages and the end. So basically how it will go is, if this was 2 volts, this was 3 volts, and this was 4 volts, and we have V2 after, the supernode will include everything. So you literally group in everything, including the end nodes and everything in between. So this is how the supernode will look like. What they call it a supernode. So we'll go here, include everything in between, everything, and the end. Supernode. It does include everything. And now we'll just treat this entire supernode as if it was like a normal node. Assume the current going out like normal, and you do your normal calculations like we are accustomed. So now you can name this whole node. Now that is basically a combination of a set of nodes. You can name this V super or something like that, VS, some name. Come on, you can't, it's a combination. Say this was VA, right? And say this was VB here. Remember now VA and VB incorporated into a supernode. So now you have to name the entire combination of stuff as a different name. Yeah? So you just remember that. It's all going to include the node before the voltage sources. It could be plural. So this would be this one here. The voltage sources, which will be everything here. Correct? And then it will include the end node, basically the node right after the last battery, which is VB. Correct. And you just group everything, literally create a node, including everything there. And while you're doing a calculation, you're basically acting like everything inside of here is just non-existent. That's a normal node, but it's not. All right? So that's how you form a supernode. That's why you have to look out for it. So you have to really be keen on when you're looking at your circuit. And it's the same thing if you had a dependent source. It's still a voltage source. So you need to treat it as is, as like that, right? So that is step one. This here is the crux of the whole. This here. All right. Nice. So step 2, you write the equation for the supernode. This here is fun. I love this. All it's gonna be, if we had this, the trick is you're literally just treating each node as like a battery. And that's the sum of all the batteries. Example, I'm placing out with all the custom. So if I had this battery here and this battery here. Say this was 5 volts and this was 3 volts, right? You understand if I add 5 and 3, if I add both of these, I'll basically just get this, which is 8 volts. Yeah? So you basically just are treating the nodes and the batteries as a battery. So our goal is, and the rule is, the sum or the equivalent sum of all the batteries and the voltages before is equal to the sum of the last battery. So all of them will add up to give you the last one. So the equation for this one, for example, so VA, make sure you know the polarities of the batteries. Okay, I don't incorporate that into the question too. So watch it. So this battery here is plus to minus, and plus to minus. So plus to minus is a voltage drop, right? So therefore the voltage for the battery will be negative. So you have to be careful with that. So this the nodal, the supernode equation for this here will be VA, because I the first one here, right? You just added them together with the polarities correctly. So VA, and there's our voltage drop, is plus or minus, will be minus 2. Next battery is a minus 4. Next one could be minus, well, minus 3. Just swap it. No need. You could write this normal way. I just forget that this was a 3. And then all those things will equal to VB. Yeah? And if you want, you could carry V. Now we could carry VB on the next side, or you could leave it like that. So you end up with VA minus 2, like minus 6, like minus 9 is equal to VB. Or you could carry that across. You could say VA minus VB is equal to 9. That is the nicer way I write it. But you need to write it like this first. All it is, as I said, you're just adding up voltage at this, voltage at the battery, in between, all of those will add up to give you the result of the last node. You must end at a node, just like we did. And so the voltage at the node before the source plus the polarity sum of all the voltage sources in between them will equal to the end node. And that's why it does form a supernode equation. Every supernode must have a supernode equation. So always remember that. All right, so there's basically two equations you will have for each supernode. The normal equation treating the whole supernode as a normal node, and then you will have a supernode equation for to link the everything inside with the outside, basically. Link the everything. That's some way. Anyway, so that is it. And with the last step, you already link equation, which we just did it. All right, so you write the equation for the supernode, which is the normal thing, where you're coming from and where you're going, nobody resistor in between, like normal, which should be the outside. Notice the outside is a normal resistor. Oops, I think it crashed. All right, resistor here, resistor here. So you treat it like normal. All right, and then you write the link equation for it, just like normal. All right, so that's how you treat supernodes. That's why you have to keep your eye open for that. Right? And the same trick I said, if you think of the nodes as a supernode as batteries, if you add up the voltages of them, they will sum to give you the voltage of the final, just like I did before. Note the polarity of each. You must know the polarity of each. Yeah, it's very important. You don't assume everything will be positive. Some stuff will be negative. All right. So, example. So I'll do this one. So if you're looking at this here, so we look at the normal circuits, just like I did before. So you label your nodes, you do this quick. Ground, you see ground here? Ground is 0, right? You see in that ground there. So I know the voltage of this entire node at the bottom here. All this here is, guess what? 0, 0, 0. The whole thing is 0. So I know the voltage at that node. The voltage I just know the 3. Why? Because it's the voltage at the node right after the battery. Let's label the other node. So we have this node here. We have a node here. Look what happened in there. Pressure. And we have this node here. Yeah, so this node here is 2. Why? Because it's the voltage node right after the battery. So we know what that is. So we have everything here. So we know VA. So label it first already. So this VA node. So I will label it for myself. And this node here is VB. But problems. This here, because you are accustomed with a resistor being in between two nodes. Also, look at here, resistor, 2 nodes, resistor, 2 nodes, resistor, 2 nodes, resistor, 2 nodes, battery, 2 nodes, but the battery kind of separate, really worry about that. All right, but all right, extra. So the reason why this battery are not treating this as a supernode is because it's not in between two nodes that I don't know the voltages for. I know the voltage that this node is 3. I know the voltage that this is 0. And I know the voltage of the battery. So they really have nothing for me to calculate. I already know the voltages. Yeah? So that way you don't treat the battery as a supernode. Yeah? You really treat it like that. You don't need to. But these here now, notice that VA, we don't know the voltage, which we just don't know. Because you have a voltage up across the resistor, we don't know where it is. We just don't know what VA is, we don't know what VB is. But we know what the battery in between here is. Yeah. So because of that, this whole thing here is a supernode. Remember what I showed you. When you form a supernode, you need the node before the battery, you need the battery, and you need the node after the battery. So when I join it, it will include here, all are going in, all are going in, all are going in, all are going in. And power, look at that, we have a supernode. In simple terms, the endpoints are the two nodes that are in between the battery. That is what the supernova for. So the endpoint was here, endpoint, 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 endpoint. And it does include everything. So that's how we did. Node before the battery, the source, node after. All these will include the supernode. And we could label it because we need to give it a label. Come on, we need to do calculations for this, right? So we can label this VS1. Yeah, just in case we have more supernodes. Yeah, so nice. So let's do the actual calculations for the second one, right? So there's the example. So we started. So we know what this is. I don't need to form a node equation for that. We know what this is. You need two nodes that we don't know the voltages for is VA and VB. So right, so let's start it. So that's like before. First thing, I am assuming my currents are leaving, but that's what custom. So here leaving, here leaving, here leaving, and here leaving. Yeah? So I form. So we know the equation is where you're coming from minus where you're going divided by the resistance in between them, right? So I see my current going up. So there you go. So we could say VS1 can be treating that entire node as that. So we are coming from, so we have from an endpoint, we have one here, we have two here, we have three here, and we have four up here. So I do, that means we have four little pieces of equations to do. So the first one is our one. So we are coming from minus we are going. So I'm going to 3. So we over 3 divided by the resistance in between them, which is 2. There you go again to 2. Same thing. Plus we are coming from minus we are going to ground divided by 3. Plus number 3, we are coming from minus we are going divided by 2. And the last one, 4, we are coming from minus we are going, which is to 2. So there's 4 here. VS1 are going to 2, right? And divided by 1. And is equal to 0. Don't forget that. Don't forget that. All right? And the last thing we need to do is to form the supernode equation, which is the most fun part. I used to love this. So the supernode link is called a link equation, right? So you basically adding up the stuff. So we starting at here, so there's 1 here, going through here, 2, and equal to 3. So I do it. So we have VA. This battery here going from plus to minus, yeah? So there's a drop, so it'll be minus, where that is 1, and that is equal to VB. And if I write it a nicer way, VA minus VB, we carry the VB across, and they carry the -1 across, will equal to 1. Yeah, and you're done.